It is given that a particle moves along x-axis according to the equation, which is x is equal to a cos omega t. Find the distance that the particle covers during the time interval from t is equal to 0 to t. So over here we can just consider that, let's say the value of time is equal to n times of t divided by 4 plus t naught. So the logic behind the way we are taking it as n times of t by 4 plus t naught is t is nothing but time taken to complete one full oscillation. So in a time of t by 4, the particle will be able to move from its mean position to extreme position, extreme position to mean position. So according to the equation, that is x is equal to a cos omega t, particle is starting from extreme position. So if we are considering that it's simple harmonic oscillation, so particle is starting from here, and our aim is to find out the value of distance traveled by it, not the displacement. So we have to add all the individual distances traveled by the particle. So if you are just taking that at t is equal to 0, particle is at its extreme position. In a time of t by 4, particle will reach its mean position. So it will travel a distance, let's say, that is equal to a. And in again a time of t by let's say it is again a time after a time of t by 4, or when time becomes equal to t by 2, or when time is equal to 2 times of t by 4, then it will travel a distance of 2a again, this amplitude a plus this distance a. And if it is 3 t by 4, it will travel a distance of 3a by 3a. Like that, we can say that if it is traveling a time that is equal to n times of t by 4, the distance traveled by the particle will be equal to nothing but n into a. Plus, if it is having some additional time which is less than that of t naught, so here you can just consider that just t naught, whatever I am writing over here, is less than that of t divided by 4. So you can write this n t by 4 plus t naught is the value of time. Now we can just consider that the value of this t naught according to this equation will be equal to nothing but t minus n t divided by 4. Now if it is in a time of nt by 4, the object will travel a distance, so we can just consider that in a time n times of t by 4, the distance traveled by the particle that will be around n times of its amplitude na. And let's say in a time of t naught, it is traveling an additional distance s naught. So the total distance traveled, we can write it as s is equal to nothing but n times of amplitude plus s naught. Now here we are having two possibilities, like where if the value of n is an even number or if the value of n is an odd number, so what will be the difference. So over here you can just consider that the value of distance traveled as naught with respect to whether n is an even number or odd number. So here in the first case, take it as in case 1, when n is even number. When n is an even number, that means if we are taking it as 0, then particle will be at its extreme position, and if it is taking it as time is equal to 2, then the particle will be at the other extreme position. Or if you are taking n is equal to 4, particle will be its the right extreme position, like that. So if n is an even number, then in a time of t n by 4, particle will be at extreme position, any of its extreme position. So we can write, if n is an even number, then after a time n t divided by 4, particle is again at its extreme position. It's again at any of its extreme position, at its extreme position. So we can find out what about the value of this S naught over here. So if the particle is at extreme position, consider the situation that if the particle is at its extreme position and in a time of t naught, let's say in a time of t naught, particle is displaced from extreme position to some distance, let's say something like this. So this is going to be the value of S naught over here. But if you are using that relation x is equal to a cos omega t, always the value of x will give the displacement from mean position. So let's say that distance is x naught. So we can write the value of S naught will be equal to nothing but its amplitude of oscillation minus x naught. So we can write the value of S naught is equal to nothing but amplitude of oscillation according to this equation is a minus a x naught can be taken as a cos omega into t naught, a cos omega into time that we consider as nothing but t naught. So we can write the value of S naught is equal to a minus a cos omega. Omega can be taken as 2 pi divided by t into t naught. So we can find out what about the value of total displacement. We already discussed that total displacement is n times of amplitude plus S naught. So the value of total displacement can be written as nothing but NA plus the value of S naught. S naught can be taken as a minus a cos 2 pi by t into t naught, and our aim is to express in terms of t. So we know that the value of t is nothing but t minus n t divided by 4, or you can write this is equal to a into n plus 1 minus cos omega t minus n pi divided by 2. Now we can consider the second case. So consider that case 2. If n is an odd number, if n is an odd number, then we can observe that if n is an odd number, let's say the particle was starting from extreme position, and if you're taking the value of n is equal to 1, then the particle will be at its mean position. And if you're taking n is 2, particle will be at its extreme position. Again, if you're taking n is 3, particle will be at its mean position. N is 5, particle will be at mean position. So if n is an odd number, then after a time that is equal to n times of t by 4, the particle is at the mean position. Particle is at the mean position. So if the particle is at mean position, and if you are finding out its displacement from mean position, so according to the equation, like if you are in a time of t naught, particle is traveling a distance, take it as S naught. So it is basically representing the value of displacement only according to the equation x is equal to a sin omega t. So you can write the value of its distance traveled, the value of S naught will be equal to, we can take it as a particle is starting from mean position, we should use that equation a sin omega t, and over here the value of time is nothing but a sin omega into t naught, and the value we can take it as a sin omega is 2 pi divided by t, and the value of t we can write in term t naught we can write in terms of t, that is t minus nt divided by 4. So we can write as we got the value of s naught, so we can write the value of total displacement, that is n times of a, amplitude of oscillation, plus a into s naught, that is a into sine 2 pi by t into t minus nt divided by 4. So you can write the value of s is equal to nothing but n into a plus a sine omega t minus n pi divided by 2, or you can write the value of s is equal to a into n plus sine omega t minus n pi divided by 2. That will be the value of its displacement.